K. This one's T. This one's G. And this one's A. And then we're going to connect K to G so that we get two triangles, because our proofs are about triangles today. All right, what we are given is that segment AG is congruent to segment KT, comma. We're also given that segment KA is congruent to segment TG. What we are trying to prove is that the triangles are congruent. So we're going to say triangle AGK is congruent to triangle TKG. So go ahead and make sure you have that information written down, because if you don't have that written down, the proof won't really make sense. And then as we work today, I'm just going to use 2 or 3 colored pencils just to kind of mark up, so that way things are kind of like looked at. And then I'm going to use the same colored pencils tomorrow when we do the notes. So I'm just going to use orange and blue first, I guess. All right, so we're doing a 2-column proof today. So we have our statements, and we have our reasons, how feeling? All right, number 1, our first statement. What is our first statement going to be? What's our first reason? Good, that's a statement. Segment AG is congruent to segment KT. And what else are we given? Segment. All right, now the textbook that you guys do your homework out of, I know you guys don't actually see the textbook, but that's where the homework comes from. They don't like putting 2 things into one statement here. I always do. So today on your practice, you'll see this written as like 2 different steps. It'll be step 1 and then step 2. But both the reasons will be given. I just like putting them in the same step because, I don't know, they're both given. All right, so as I look at this, I'm going to label this part here. AG is congruent to KT. So here's AG is congruent to KT. And then we have KA is congruent to TG. So KA is congruent to TG. Yes, I'm using the same color, but I'm using different amounts of tick marks. This is just to show that this was our given. Okay, so that's going to be the first thing that you want to do when you're given information, is you might want to draw out the pictures. Drawing out the pictures and actually marking them is going to be really helpful. If you ask for help today on the practice, the first thing I'm going to do is take a whiteboard and draw a picture of what it is. It doesn't have to be a pretty picture, but a picture just to at least be able to show what we're marking. Okay, now our goal, in order to see that these triangles are congruent, I need to use one of these theorems from yesterday. Side, 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 angle, angle, side, side, angle, side, or angle, side, angle, or hypotenuse, leg. Do we have a right triangle? No, so not that one. Okay, which one of these 4, or which 2 might be good options based on what we were given? We might do side, angle, side, or we might do side, side, side. Why? Yeah, so far we just have 2 sides, right? So either we need the 3rd side, or we can try and figure out an angle between the 2 parts. Okay, so two sides, these are the only ones with two S's. So is it going to be easiest to prove this third side is the same, or should we try and involve an angle? Yeah, the third side. So step number 2 here. Okay, this is the part that we're coming up with that we should see in our heads. It was asked to you yesterday what theorem we could use to prove this. And it was side, 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 because this KG is congruent to itself. So KG is congruent to KG. And what do we call that theorem or property? Yeah, remember when you look in the mirror and you see yourself and you think of Mulan? Who is that girl I see staring straight back at me? Yeah. When will my reflection show me who I am on the inside? It's reflexive. Okay. Miss Morrell, you're such a good singer. Thanks, guys. All right, reflexive property. Yeah, it's a Wednesday. We're halfway through the week. You guys gotta start waking up. We had 2 days to be tired. We did.
Maybe that's why you woke up earlier than that.
All right. Last step, step number 3. Do I now have enough information to say that all 3 sides are the same? Did we mark all 3 sides? Yes. So triangle AGK is congruent to triangle TKG. And our theorem that we're using for that is the one from the foldable. Was it side, 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 angle, side, angle, or angle, angle, side? What? We marked angles? Nah, just sides. So just the side, side, side. We did it. Yay. I also kind of woke up this morning and I just kind of realized that I've just been like meh lately, and then I decided to just not be meh today. Do you know what I'm saying? Like at some point it's a choice to be meh. Today I was like, I'm not going to be meh. All right, here's our new theorem that's really, really important. It's not really a theorem. I don't know what it is. That's the part that's confusing about it. So I'm going to put like some exclamation points, some arrows. This is really important. It's a big deal today. It's a really long thing. You ready? It's called corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. So, because it's really long, we do a handy-dandy abbreviation, and we call it CPCTC. Really important today. Just all the things over here. Okay, a couple of your proofs today in your practice are going to involve this, so it's important that you have it. Okay, and what this is going to do is this tells us that if 2 triangles are congruent, I'm going to abbreviate that congruent symbol there just to save some space. If 2 triangles are congruent, so congruent triangles, then their corresponding parts, what does corresponding mean again? That's adjacent. That's close. They're kind of next to each other. Same place. They're matching. Good. So then the matching parts are congruent, which is what we said already 2 lessons ago. Okay, we just need a way to say this as a reason, and so this is where it comes from. So if we take a look at this, I'm going to flip back really quick. That's what we did on this example right here. When we knew that these 2 triangles were congruent, we were able to like match up the matching parts. That's all it's saying, is that now that we know these are congruent, we know which parts match with which parts. Okay, so way back in my day, when I was in 9th grade, we took geometry. We did it different. We took geometry in 9th grade, and then we took algebra, intermediate algebra as 10th graders, and then we took algebra 2 as 11th graders. I don't know why. It's just the way my school did it. But way back in my day, my he was a teacher. His name was Mr. Landuck. He would literally, we would have our textbooks open. So if we were doing today's lesson, this is how he would teach you guys. The ASA postulate. An included side is the side located between consecutive angles of a polygon in triangle A, B, and C. At the right, AC is an included side between angle A and C. Like, I kid you not, like, no one was awake in that class. It was insane. So, he literally just, like, opened up the textbook and literally just read us the textbook. If you didn't know, this is where we get our lessons from, is this textbook. But textbooks are boring, so I choose to say, bye, textbook. But anyways, no one understood what was going on in that class. Somehow I could understand the textbook because I just read it myself. And I was like, if he's going to read us the textbook, I can read the textbook. And then one night after gymnastics practice, Maddie St. Aubin was at my house and we were studying for geometry. And she was crying at my kitchen table. It was 11 o'clock at night. And we had a test about this on the next day. And she said, how will I ever remember corresponding parts of congruent triangles are congruent? And I knew that she really liked cats. So we're like, okay, we'll see cats. And then we came up with cats pooping carefully in the corner. And that's how she remembered CPCTC. And then she did a proof by herself. And it was so exciting. And then also my teacher was really, really bad. So we had like study group in the morning that we would just all go to the library. And pretty much I was just teaching everyone geometry in 9th grade. So that's why I became a teacher. Was because I was like, cats pooping carefully in the corner. Easy. If I can do that, I can do anything. So that's why I became a teacher. Literally because of this. You guys don't seem excited. Okay. All right, number 2. Last one. It's exciting, people. I wouldn't be here without this. I would be being a dolphin trainer. That's what I was going to be. Without cats pooping carefully in the corner, that's where I would be. I'd be at SeaWorld. Okay, well, she could have, but it's the corner. All right, number 2. Here we go. We're going to draw kind of this, like, figure 8 triangle situation that's happening here. Like that. It's not a very good picture. In fact, I can tell right away that these aren't congruent. But guess what? We're going to prove that they're congruent. That they're supposed to be the same, even though my picture's terrible. All right, this is F up here. This one's G. This one here is K, the one in the middle. And then this one up here is M. And then this bottom one is P. So make sure you have that labeled correctly first, otherwise that might be a little challenging to do this problem. All right, our given. We have a couple things that we are given to us. We know that angle G is congruent to angle M. And we know that K is the midpoint of FP. What I'm hearing from you guys is you think I should just read out of the textbook. I'm going to start doing that. Tomorrow we're going to learn flow proofs from the textbook. It's going to be great. I'm just kidding. All right, prove. What we're trying to prove is that FG, segment FG, is congruent to segment MP. So go ahead and set up your table. You should be able to know what goes in each column. This one's going to be a 5-step proof. I'm going to leave a couple spaces in between, so I'm not going to label all the 5 steps right now. But it will be a 5-step proof. Is it not working? It was working this morning. There we go. All right, so for our first statement, we have our given angle G is congruent to angle M. Angle G is congruent to angle M. And then we also know that K is the midpoint. So like I said in your practice today, they're going to label this as 2 different steps. I'm going to just write K midpoint, not K is midpoint, because that's going to take up too much room. K is midpoint of FP. But in my brain, why do 2 different steps if it's the same reason? Okay, what's our reason for both of those? Given. All right, now our goal is going to be to show that FG, this part over here, is congruent to MP, this part over here. We don't know anything is parallel. We don't know anything is the same. We don't know any bisectors as far as this goes here. So what we're going to have to end up doing is first we're going to prove that these triangles are the same. If I can prove this triangle on the left is the same as this triangle on the right, then I can pair those together. So that's going to be my first step, is to pair those parts. So step 2, I'm going to use this idea that K is a midpoint. If K is a midpoint of FP, what do I know about midpoints? They're right in the middle. So what 2 parts would be the same of FP if K is in the middle? F to K will be the same as K to P. That's okay. You had the right idea. And what do we call that theorem that tells us that when we have something right in the middle, the 2 parts are congruent? And if you're not sure, it's over on this wall by the door. It's near the clock. Whoa, midpoint theorem. Amazing. Okay, I'm going to mark that with my colored pencil. I just want the different color here. Okay, FK is this side, is congruent to KP, this side. So that's going to be a big part of today. If you need help on your work, that's going to be probably the number 1 thing I'm going to do, is draw it out and mark it up as we go. Highly recommend drawing out your work. Okay, number 3. Now we're kind of stuck. We've used all the given. We used this idea that G is congruent to M. We used this midpoint. Omar, like literally like 2 more minutes. Just put your phone away. 2 minutes. You can do it. All right. So what I need to do is I need to think back to my triangle theorems here. Based on your picture, when you look at your picture, which one might we be able to use? We could maybe use angle, side, angle. We might be able to use angle, angle, side. And we might even be able to use side, angle, side. We have 1 angle and 1 side so far. So we for sure probably know it's not side, side, side. Do we know we have a 90-degree triangle? No. So it's going to be one of these three. So we have to figure out either another angle or another side that's congruent based on the picture. We have no further information than the picture. Do I know that there's a congruent side or a congruent angle based on the picture? Yeah, angle. What angles are going to always be congruent? Yeah, these ones in the middle. What do we call angles that are across from each other? Vertical. Good, and I really like, Caden already said it, he used 3 letters here. So G, K, F, that's the one on the left side, is congruent to angle. And I need the one on the right side here. MKP, or we could do PKM. And what kind of angles were those again? Vertical. Okay, if you want to highlight that with a color, you can. If you're not using colors, you should still be marking up your picture as you go. So even if you're not using these colored pencils, I realized this morning as I was cleaning up some desks that those need to be restocked. So if you're not using colored pencils, you should still be marking it on your picture. All right, so now do I have enough information to say that these triangles are congruent? Yeah. How many angles do I have? Yep, I have 2 angles on each. So how many do they each have? They each have 2 marked. How many sides do they each have marked? 1. So is that going to be, when you look at it, is it angle, angle, side? Or is it angle, side, angle? Is the side that's marked in between the angles? Or is it side that's marked outside the angles? Yeah, it's outside the angle. So that's going to be angle, angle, side. Because this is not between the blue and the yellow here. It's on the outside. So we can say the triangles are congruent. We need to come up with our congruent statement. The first one doesn't matter the order we go in. So we can say a triangle say it again. GFK. I thought you said PFK, and I was like, no. GFK, yep. Okay, Abdulatif did our first one for us. Our second one, we have to now match with what it goes with. So G matches with what on the other triangle? M. Now it goes GF, so we want MP, and then we end at K. And what was that theorem from the last foldable? Was that side, 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 angle, side, angle, side, angle? I'm missing one, or hypotenuse leg. Good, it was angle, angle, side. That side was not connecting the angles, so that side's on the outside. Okay, now you're like, dang, we did it, we're done. No, no, no. No, no, no. We're not there yet. That's not the proof. The proof is that these two parts are the same. So now that I know that this triangle is exactly the same as this triangle, can I show that these two sides are the same? Yeah, because the triangles are exactly the same. We're saying it's a copy and paste. So step number 5, when I look at FG, and we're writing it like that because that's what was in the proof, was FG. That's the first 2 letters. What is that going to match with over here? MP. Because we had congruent triangles. So corresponding parts, these are corresponding parts of the congruent triangles are congruent. Cat's pooping carefully in the corner. All right, you guys crushed that. Here's the thing, the homework is a little long. I am going to give you some time to work tomorrow, but that doesn't mean that you shouldn't work today. The reason why you get work time today and tomorrow